Hi, remaining questions.
The next question is explain various steps involved in debugging. Debugging is the process of identifying and fixing errors or bugs in a software program. It is a critical and iterative part of software development that involves systematically finding, isolating, and resolving issues to ensure the correct functioning of the code.
The first step is to reproduce the problem or bug. Understand the specific conditions or inputs that lead to the undesired behavior. Reproducing the issue is crucial for isolating and understanding the root cause of the problem. The second step is to understand the code. Review and understand the relevant parts of the code. Identify the variables, functions, and control flow related to the problematic behavior. A solid understanding of the code is essential for effective debugging. The third step is to use debugging tools. Utilize debugging tools provided by the development environment, such as breakpoints, watches, and step-by-step execution. Debugging tools help developers inspect the program state at different points, track variable values, and step through the code execution. The fourth step is print statements or logging. Insert print statements or log messages strategically in the code to output specific values or messages during execution. Logging helps developers track the flow of the program and the values of variables, making it easier to identify where issues may arise. The fifth step is to isolate the issue. Narrow down the scope of the problem by identifying the specific code section or module causing the undesired behavior. Isolating the issue helps focus debugging efforts on the relevant parts of the code, making the process more efficient. The sixth step is to check inputs and outputs. Verify the inputs and outputs of functions and methods involved in the problematic behavior. Ensure that data is processed correctly. Incorrect inputs or outputs can be a common source of bugs, and checking them is crucial for identifying and fixing issues. The seventh step is to examine variable values. Inspect the values of variables at different points in the code, especially before and after critical operations. Understanding variable values helps identify when and where unexpected changes or errors occur. The eighth step is to use breakpoints. Set breakpoints at specific lines in the code to pause execution and inspect the program state at that point. Breakpoints allow developers to examine the code's behavior step by step and identify issues during runtime. The ninth step is to step through code. Execute the code step by step, either using breakpoints or single-stepping functionality, to observe the program's behavior. Stepping through the code helps identify the exact location and conditions under which issues occur. The 10th step is to consult documentation and resources. Refer to documentation, online resources, or community forums for insights into common issues related to the programming language, framework, or libraries being used. External resources can provide valuable information and solutions for common programming issues. The 11th step is to implement fixes. Once the root cause of the problem is identified, implement the necessary fixes or changes to the code. Fixing the issue based on the identified root cause is the final step in the debugging process. The 12th step is to test the fixes. After implementing fixes, thoroughly test the code to ensure that the issue is resolved and that the changes do not introduce new problems. Testing helps validate the effectiveness of the fixes and ensures the overall stability of the code. Debugging is often an iterative process, and developers may need to repeat these steps multiple times to address different issues in the code. The key is to approach debugging systematically, leveraging tools and techniques to identify and resolve problems efficiently. The fourth question of first part is briefly explain the process of software configuration management. In software engineering, software configuration management (SCM) is a process to systematically manage, organize, and control the changes in the documents, codes, and other entities during the software development life cycle. The primary goal of SCM is to ensure the integrity, reliability, and traceability of software products. Here is a brief overview of the process of software configuration management. The first step is configuration identification. This involves identifying and defining the software configuration items, SCIs, that make up the software project. SCIs can include source code, documentation, libraries, executables, and other artifacts. Activities, naming conventions, versioning, and labeling are used to uniquely identify and track each configuration item. The second step is configuration control. Configuration control is the process of managing changes to the identified configuration items. It involves establishing baselines, controlling changes, and ensuring that only authorized modifications are made. This helps in maintaining stability and preventing unauthorized alterations. The third step is configuration status accounting. Configuration status accounting involves recording and reporting the status of configuration items throughout the development life cycle. It provides visibility into the state of the software at any given point. Regularly update and maintain configuration status records, including version information, change history, and the current state of each configuration item. The fourth step is configuration auditing. Configuration audits are reviews conducted to ensure that the actual configuration of the software aligns with the planned configuration. This helps in verifying the completeness and correctness of the software product. Conduct regular audits, such as functional configuration audits, FCA, and physical configuration audits, PCA, to assess compliance with the configuration baselines. The fifth step is build and release management. Build and release management involves creating builds of the software from the configuration items and managing the release of these builds to various environments: development, testing, production. The sixth step is version control. Version control, also known as revision control or source code management, involves tracking changes to source code and other artifacts over time. It enables collaboration among team members and helps manage codebase evolution. Use version control systems, for example, Git, SVN, to manage changes, branching, merging, and collaboration. The seventh step is baseline management. A baseline is a snapshot of the configuration items at a specific point in time. It serves as a reference point and is used for comparison and auditing. Establish baselines for different milestones in the software development life cycle, such as the initial baseline for a new release, and maintain them throughout the project. The eighth step is change management. Change management involves the systematic handling of changes to the software configuration. It includes the submission, evaluation, approval, and implementation of change requests. By following these SCM processes, development teams can effectively manage and control changes to software configurations, leading to more reliable and maintainable software products.